Suppose I have a boat in still water and needs to move the other side of the river. It directly crosses the river with a constant velocity. Look the video. Here is the boat and crosses the river. Now here a little battery operated car placed on a treadmill, and treadmill is not moving. So the car will move directly the other side with a constant velocity. It is a similar situation as like a river. Slow motion. Now this time the boat wants to move across the flowing river with same velocity that it had in still water, but river is carrying it to the right at another position as shown in this video. This is your boat and the direction of motion of river, velocity of boat with respect to water, flowing water, velocity of water with respect to shore, and this is your resultant velocity of boat with respect to shore. And the boat is moving in the direction of VBS, that is in the direction of resultant velocity. Here is the car on a moving treadmill. Here is the car on a moving treadmill. This is the velocity of treadmill, direction of velocity. This is car, direction of velocity of car as before, direction of velocity of car as before, and this is the resultant velocity of car with respect to the ground. Slow motion. Now this time the boat must go across the river directly across. However, the river is flowing to the right. So which direction should we attempt? The answer is it must against the stream at an angle. Look this video. Where should be the velocity of this boat? This will be the direction of velocity with respect to shore. This is the velocity of water and this is your resultant velocity. Boat will go in the direction of resultant velocity. This is the result. Now here is my little car on the treadmill and I want it to cross directly across. For it, I have to move car at an angle against the treadmill velocity. Look this in this video. Treadmill velocity, direction of velocity of car, vector addition, the resultant velocity, direction of resultant velocity. The mathematical description of the problem is given. Here. VR is the velocity of river. VBR is the velocity of boat with respect to river. VR is the velocity of river with respect to ground. And let O is the initial position of the boat. A is the position directly across the river and B is the position where boat reaches after crossing the river. The distance AB is called drift. This distance AB is called drift. This is the direction of positive direction of x-axis and this is the positive direction of y-axis. Let unit vector along x-axis is I cap and along y-axis, it is j cap. It is j cap. We can write Vr vector as Vr I cap, and VBR vector, since VBR is along in this direction, the component of VBR along y-axis will be VBR cos theta, and along negative direction of x-axis it will be VBR sin theta. So we can write VBR, velocity of boat with respect to river. VBR is equal to VBR cos theta, VBR cos theta j cap, as it is in the direction of y-axis, minus VBR sin theta I cap, as it is in the negative direction of x-axis. Now we know that VBR is equal to VB minus VR. Here VB is the velocity of boat with respect to ground or shore, and velocity of river, VR is the velocity of river with respect to shore. So velocity of boat will be equal to VBR plus VR. Substituting above values, we get VBR cos theta j cap minus VBR sin theta I cap plus VR, value of VR vector, VR I cap. It can be written as VR minus VBR sin theta I cap plus VBR cos theta j cap. If W is the width of river, then time taken by the boat to cross the river is T is equal to displacement along y-axis upon velocity component along y-axis. It is VBR cos theta. VBR cos theta. Now the displacement along x-axis when the boat reaches on the other bank is given by, it is also called drift. Drift is given by drift x is equal to velocity of the boat along x-axis, which is Vr minus Vbr sin theta. Velocity along the x-axis, velocity of the boat along the x-axis is the component of I cap in this equation. And T is W upon Vbr cos theta. Let it is your equation 1, it is 2, and drift x is the equation 3. Now 3 special cases are condition when the boat crosses the river in shortest interval of time. Now the T is given by T is equal to W upon W is the width of river upon Vbr cos theta. T minimum is equal to shortest time is equal to W upon Vbr cos theta minimum. Cos theta maximum. Cos theta should be maximum for minimum value of T. So we will write here maximum. It should be maximum. As cos theta maximum is 1, that is theta corresponding to maximum value of cos theta is 0 degree, as cos 0 degree is 1. So T minimum will be that is shortest time will be W upon Vbr into 1, that is W upon Vbr. It is the shortest time taken by the boat to cross the river. For it, the direction of boat, velocity of boat will be along OA. This will be the direction of velocity of boat. With respect to river. Let it is your equation 3. Now the second condition is the condition when boat want to reach point A. Here is the point A, just across the river. Point A, that is at a point just opposite across where it started. For it, the drift x should be 0. That is x is equal to 0. The value of x is velocity Vr minus Vbr. It is the value of x, Vbr sin theta into W upon Vbr cos theta. It should be equal to 0. It is the value of x. Vr, it means Vr is equal to Vbr sin theta, or Sin theta is equal to VR upon VBR, or theta is equal to sin inverse VR upon VBR. Hence, to reach point A, the boat should move at angle theta is equal to sin inverse VR upon VBR upstream from OA. Now if VR is equal to VBR, VR is equal or greater than VBR, the boat can never reach at point A. Boat can never reach at point A, because if VR is equal to VBR, then sin theta will be equal to 1, that is theta will be equal to 90 degree, and it is just impossible to reach at A if theta is equal to 90 degree. And if VR is greater than VBR, then sin theta will be greater than 1, which is also not possible, which is also not possible. Shortest path. If W is the width of river and X is the drift, then path length will be equal to S. It is given by S is equal to square root of W square, this square, since this angle is 90 degree, W square plus X square. So for minimum S, drift X should be minimum. Now two cases are possible. Case first, when VR is less than VBR, In this case, two cases are possible. Two cases are possible. When VR is less than VBR. In this case, for minimum S, minimum path length, X should be equal to 0. And as a result, S minimum is equal to W, or theta is equal to sine inverse VR upon VBR. Sorry, at theta. When VR is greater than VBR, in this case x is minimum, where dx upon d theta is equal to 0. That is, d upon d theta of x, this, is equal to 0. On solving this, we get minus VBR plus VR sin theta is equal to 0. That is, theta is equal to this. Now at this angle we find x minimum and then s minimum, which comes out to be s minimum is equal to W VR upon VBR at theta is equal to sine inverse VBR upon VR. VR upon tan tan.